Hey, it's Tony here, and today I'm going to show you some processing steps at a pretty high level using Siril and Photoshop to process an image of M57, the Ring Nebula. Now, this image was the result of less than ideal capture conditions, and so in the image you'll see some very slightly oval-shaped stars, which I'll show you some tips and tricks to try and address that. And a few other things that we'll play around with. So with no further ado, let's get started. I've already got the image is already opened in Siril. So this image is a result of being aligned and stacked using Siril. It was, I think, around 48 times 5-minute subs. So just a few hours of capturing M57. And right now I'm in linear view down here at the bottom. I'm going to switch over to auto stretch view. And auto stretch view doesn't change the image itself. It simply allows you to process the image and see what's going on. The nice thing about this is what's very cool on this image, I thought, was here's M57. You can see an outer halo in Messier 57, which you don't always see in images that you see online, not always. But interestingly, there's a few galaxies as well. There's one here. There's one right just here, a little speck. And I even saw one down here as well, right at the very bottom. So very, very interesting field capture. All that said, the first step in the workflow is I'm going to focus primarily on the M57 object. So what I'm going to do is I'm going to crop this image quite a bit, actually. And so the first thing I'm going to do is I'm going to hold down my left mouse button and drag a rectangle. And so this would be about, 50% crop. So I'm going to do a pretty drastic crop. Let's say around a 75% crop of Messier 57. Actually, let's increase this a little bit. Let's include this galaxy at the bottom here because it's a very interesting object also. And then I right click on crop here and crop, and then it goes ahead and crops the image. So lots of things going on in this image. First and foremost, there's background noise. If I use my mouse wheel to zoom in, you can see the stars here. These are not circular stars by any means. They're a little bit oblong. Like I say, the capture conditions were not optimal. As a result, the guiding and the tracking was trying to keep up with the poor seeing conditions. And we'll zoom back out here on the image. And so the first thing after the crop is, let's go to 100% image view, which I click on here at the bottom here. Takes me back to 100% image view. So I'm going to do, first and foremost, a plate solve on the image. And so to do that, I go to Tools, Astrometry, Image Plate Solver, and I type in M57. Then I click on Find. Now, what a plate solve does, at a super high level, it kind of tells Siril what objects it's looking at and some of the capture factors that were used to capture the object. And that will help Siril in future processing steps that we'll see in a few moments. So I'm going to click on OK. And then the plate solve takes place. And you can see there that Siril now understands some of the capture parameters, the focal length that was used, the pixel size of the camera that was used to capture the image, and a few other details. So that's the plate solve. I'm also going to do what's called a background extraction. And this is if the background of the sky here has any kind of gradient. So for example, it looks to me like the background is a little bit darker here than maybe on the other side of the image. Anyway, let's go ahead into scripts, Python scripts, processing, and there's a script here that I've downloaded called AutoBGE. I'm going to go ahead and leverage that. I'm going to run the script, and you see it brings up a dialog. I'm going to just keep the defaults, click on process, and straight away the script is doing its magic by measuring the background. It's doing some processing, and it's pretty quick, mainly because I've cropped the image quite a bit. So it's not a super large image. So let's minimize that. And at least to my eye, it looks like the background is a little bit more even. Then the next thing we want to do is a color calibration. So go into here, image processing, color calibration, and we are going to select spectrophotometric color calibration. We click on that, and I've already selected in some of these drop downs here, my image sensor that's used in my camera was a Sony. I happen to have in my camera a UV and IR block filter, so I selected that. And then I'm going to click on OK. And what Siril does is it looks at a online or locally installed catalog, and then kind of matches that information to what the colors should be of this image if we were looking at it right there, right by the nebula without a telescope with a human eye, basically. And so we click on OK, and we can close this. And then one thing I do, and again, this is almost like personal choice, but I like to play around with it anyway, is to remove the green noise. So I go to image processing, remove green noise, and I click on apply, and it makes a subtle change to the color of the image. And again, that could be personal preference on whether you do that or not. Now, the next thing I'm going to do, unique, I will say it's unique to this capture and the capture conditions. This is what I found with this particular image. Your experience may be different. And so first of all, I'm going to go into auto stretch, and I'm going to select linear. And so now you're looking at the image with no stretching taking place at all. I'm going to go into scripts, Python scripts, and then VeraLux, and use the VeraLux hypermetric stretch script. I'm going to run the script. Now, for this image, the sensor profile listed here, I'm going to select the camera sensor that's in my camera. And I'm going to change these settings here a little bit, and you'll see why in a few moments. There was something unique to this image, and I've already previously processed this, so in another workflow, so I know this process works. So I'm going to set the target BG to 0.05, and I'm going to select the color strategy. This, in essence, is the strength of the color of the image after processing at a very high level. I'm going to take this down to about 25% of the way along. I'm going to click on live preview, and you can see there's the image. I'm going to zoom in a bit, drag over, and you can see, again, an experience of not great seeing conditions, not super great definition of the nebula itself. I'm going to click on auto calc here. And when I do that, the image goes a little bit funky. That's okay for the time being, and I'll explain why in a few moments. So I'm going to click on process. And now we are complete. Let's close this out. So this is far from done, by the way. And you can see the stars are looking kind of weird and got this weird ghosts around the stars. We'll fix this. The reason I did that step was I found for this particular object and this particular image, if I did a full stretch, then I was finding some artifacts in the image here, almost like square pixels in the image. But by following this process, it seemed to have resolved that situation. Again, every capture is different. Your experience may be different. I'm showing you an example of what I did for this image. And so the next step then is I'm going to go ahead and I'm going to do a star removal. There are several tools out there to do star removals. And typically the reason we do star removals is we want to process the nebula by itself and then process the star separately. And so the tool I've used for a while now is a tool called StarNet. I know there's other tools out there. There's one that's just appeared, which is the Cyclone Zenith tool. I definitely encourage you to try it out as well. So for this example, I'm just going to use the tool that I know quite well. And so I go to image processing, star processing, and then StarNet star removal. And I'm just going to accept the default settings. I'm going to click on execute. Now, on my computer, I have a pretty powerful computer, pretty powerful processor, lots and lots of memory. I think I've got 64 gigabytes of memory, and I've got a pretty powerful graphics processing unit. So this process didn't take any time at all. And you can see now the stars have been nicely removed. If I zoom in using my mouse wheel, you can see there are no artifacts in this image. Well, actually, I'll correct myself. There seems to be some very slight artifacts here, but we'll deal with that in a moment. Let's go back to the 100% view by clicking on this button down here. 100%. And then let's just start to process this nebula only. So the first thing I want to do is I want to go ahead and do a repeat of that stretch that I did earlier. So let's go ahead, Python scripts, VeraLux, hypermetric, run the script. This time, I'm going to accept the defaults, but I've already done a color strategy on the previous stretch. So I'm going to take this all the way down to 0 and click on Auto Calc. And then I'm going to click on Process. Now you can see here, if I close here, the image is definitely changed. I'm in linear mode. It's got a kind of a weird background. You can see a few artifacts from the StarNet processing, and I'm going to fix these. So the first thing I want to do is the nebula looks really bright, overly bright. And so I'm going to go ahead and go into another script, Python scripts, processing, and this one is called HDR multi-scale. So it's high dynamic range multi-scale. Run the script. What HDR does is it gives you the ability to essentially stretch certain parts of the image without blowing out the cores of the image, for example, and making things look too bright. So I'm going to click on Fit to Preview. I'm going to zoom in using the mouse wheel. And then I'm going to take the number of scales here down to, let's say, 3. And then the compression strength, I'm going to take this to about 2.5. I'm going to then click on Preview. And you can see here, we're now starting to get just a little bit of detail emerging in the nebula, which is quite nice. And so let's click on Apply to Siril. Click OK. And then we can minimize this out. So we're making some headway here, a little bit. Now what we want to do is let's go ahead and apply a sharpening of the nebula. So the tool I use to do that is scripts, Python scripts, processing, and sharpen. I'm going to run the script. I'm going to select non-stellar. I have no stars in this image, so I only want to sharpen the nebula part. And then I'm going to click on Apply. Now, with Cosmic Clarity, it makes, let's say, heavy use of your graphics processing unit in your computer. And so sometimes this may take just a few seconds. Sometimes it can take quite a bit of time. In my case, it's already done, already completed. So we'll minimize that. And you can see already I've started to sharpen some of the inner details of that nebula quite nicely. Then the next thing I want to do is I want to do a denoise because I've got a pretty noisy background here. And so I'm going to go into scripts, Python scripts, processing. And then I've got a tool here that I use called GraXpert. Again, there are other there are other denoising tools out there. I'm just going to use this one for this particular example video. And then in GraXpert, I'm going to select denoising. I'm just going to keep the defaults. I'm going to click on Apply. And again, I don't have a super large image because of that crop that I did earlier. So this process literally just takes 10 or 15 seconds. And you can see here on the status here, it's moving at a pretty fast clip and it's done. And you see nicely, now the noise has really come down nicely on the image. So once I've done that denoise, now I want to go in and kind of fix this background. It's looking kind of weird to me with this mottling and artifacts and whatnot. So we're going to go into image processing, stretches, and curves transformation. Now you can see here, I'm going to left click on this little square down here, and I'm going to drag this little square over. And you see when I do that, how the background darkens. But interestingly, this nice halo that we see around the nebula is not being reduced too much. So let's just take this down a little bit more aggressively. And so now I'm starting to really darken the background quite a bit. And we don't want to go too far. I'm being pretty aggressive here. But what I'm trying to do is trying to reduce so you see less of these artifacts that were showing up. Just take it down a notch more. And so we're now starting to lose that outer halo a little bit. But let's just leave it like that. And then click on apply. And we can close this out. Then the next thing we want to do is go ahead and we want to save this file. So let's go ahead and let's just save it. Let's call it Nebula. So we'll go ahead and do that. Nebula. I'm going to save it as a FITS file. And now let's look at the stars image. So this is referred to as a star mask. Double click on that. And you can see, as I said earlier, we've got some really odd shaped stars here. And we're going to attempt to fix that. So there is a tool in Siril under image processing, star processing, called the resynthesis tool. The first thing I want to do is I want to click on this little gearbox here because I want to select the stars that I'm trying to fix. And the profile type that I've used is I typically use Moffat, only because I've gotten slightly better results, in my opinion, using this tool. And then I also changed the roundness threshold. Basically, if the stars were really, really elongated, I'd probably keep this to around 0.5. But because they're only slightly out of roundness, I'm actually going to change this to 0.1. And then the next thing I want to do is, okay, now show me all those stars that fit this profile. So I click here, and you see all these orange circles appear around the stars. So this is basically the tool saying, okay, these are the stars I'm going to fix. I'm going to close this out. And then the next thing I want to do is click on here, full resynthesis. So it's going to apply basically a synthetic image for the stars. So to be clear, I'm not adding to this image. I'm simply rounding out the stars. And so I'm now going to go back and you can see now the stars are looking much, much rounder. Let's go into the star processing tool again. Click on that gear icon. And then we're going to click on this here, this delete button here, just to remove those orange circles. Close. So look at that. We've got some nice rounded stars. So let's go ahead and save this image. And we're going to go down here. And let's just call this one, let's call it Star Mask. And click on Save. And we're going to save it as a 32-bit FITS file. Click on Save. And now we're ready to bring the two images together. And one tool I've used to do that under image processing, star processing, is this star recomposition tool. So let's click on it. Yes. And the first thing we do in this tool is select the background. So that was the nebula image. So double click and you see the nebula appears. Now we want the star image. So that was the star mask image. And you'll notice here, those stars do appear. We want to go ahead and click on Advanced at the bottom here. And you see the type of stretch says Modified Arc Sign Transform. I'm going to leave it like that. And then there's a stretch factor here that I'm going to go ahead and move this up a little bit. You see when I do that, the stars start to grow a little bit. We don't want to go too crazy because otherwise the stars will just look quite strange. So let's leave it at around 1.3 for this particular example. Click on apply, and then I'm going to click here, and I'm going to click generalized hyperbolic transform, and then I'm going to stretch again. And when I do this, the stars will brighten a little bit more. You see, I've gone way overboard there. It just doesn't look natural to me. So let's just back off a little bit and just make it a very, very subtle stretch. Again, you know, the stars to my eye, they still look a bit bloated. But again, we're going back to scene conditions weren't that great. And then click on apply and close. And now if I zoom in with my mouse wheel here, you can see that we've got a pretty nice image given what we had to play with. However, I want to call out a couple of things. One is you can see there's some weird dots here. These are either a result of StarNet processing, stretching. It could be hot pixels in the image sensor. So we're going to go ahead and fix those in Photoshop. So I'm going to go ahead and I'm going to save this combined file as a TIFF file. Click on save. I'm going to save it as 16-bit and then save. Let's go ahead and minimize Siril and then open up the file in Photoshop. So here it is, the TIFF file. And let's go ahead. I'm going to zoom in Photoshop, and then let's look at these little dots here. The first thing I'm going to do is I'm just going to copy the layer using Control-J in Photoshop. And then I'm going to go ahead and do a filter, and I'm going to do a noise reduction, and I'm going to do dust and scratches in Photoshop. Now you can see I played around with this before, this image. So these settings here actually magically reduce the pixels straight away. But if I take this threshold back to the other way, you can see those things that reappear. So I found if I drag this, they start to reduce a little bit, a little bit more. There we go. So about 106. Let's be a bit more aggressive. Let's take it to about 100, and we click on OK. So those pixels have gone away. Then the other thing that I can do with this image is I can go over to here. I'm already zoomed in, and I can go in to filter, camera raw filter in Photoshop. And if I zoom in, then I'm going to go ahead, I'm going to play around with the saturation. So I can go overboard. I can make this nebula look really, really colorful, or I can back it off a little bit so it looks a little bit more natural, at least to my eye. So let's keep it to around 15 on the saturation. The vibrance, I'm going to increase to 5. So vibrance is basically a way of increasing saturation without blowing out other details. And then clarity is one I've used, take it up to about 5, that kind of increases some of the edge contrast in the image. So there's many other settings in Camera Raw you can play around with. I'm just showing you very high level things to play around with. So click on OK. And if I unhide this layer, you can see the very subtle difference we made. And you notice here, here's those artifacts that appeared in the early processing in Siril. And I'm not totally sure why. I can certainly, if I wanted to, I can use Photoshop to blur those out. Let's go ahead and do that. So at least you can just see some of the things you can do within Photoshop. Let's reduce the size here. And if I click here, you know, I very, very, very subtly kind of blur these out to make it just a little bit better, at least to my eye. If you wanted to get a bit more creative in Photoshop, it's always that sort of borderline of playing around with an image. Is it truly an image you captured, or are you over manipulating it? But I'm pretty cool on playing around with some of these tools. This is the dodge tool in Photoshop. And so what it can do is if I click a couple of times, maybe once, I just brightened up those inner stars. They're already there, but I just simply went ahead and brightened them. Now, if I press Control-0, you can see that we got a pretty nice looking image. It's not perfect because the stars still look a bit ghosty to me, but they're certainly not oblong like they were before. And you can still see that nice hydrogen halo around M57. So encourage you to play around with these steps. There's many things you can do with Siril and many things you can do with Photoshop. But I want to thank you for your time and enjoy. Thank you.